A cosmic question: what if our sun became a black dwarf? The universe is a place of constant change. Stars are born, they shine brightly for billions of years, and eventually, they die. Our sun, the heart of our solar system, is no exception. But what happens when a star like our sun reaches the end of its life? What if our sun became a black dwarf? This question takes us on a journey through the life cycle of stars. It forces us to confront the immense timescales of the cosmos, and the profound implications of stellar evolution for life as we know it. The journey begins with understanding the life and death of stars like our own. It's a story of nuclear fusion, gravitational collapse, and the eventual fading of even the brightest stars. The life and death of stars, from blazing glory to faded embers. Stars, those magnificent celestial bodies, have a life cycle that is as dramatic as it is beautiful. Stars are born from vast clouds of gas and dust, drawn together by the irresistible force of gravity. These clouds, known as nebulae, are the cradles of star formation. As this material collapses, it heats up, eventually reaching temperatures and pressures high enough to ignite nuclear fusion in its core. This fusion process is the engine that powers a star. This is where the star's life truly begins. It marks the birth of a new star, a beacon of light in the vast darkness of space. Our sun, like most stars in the universe, is currently in this stage of its life. It is a stable, middle-aged star, steadily burning its hydrogen fuel. It's fusing hydrogen into helium in its core, releasing the energy that bathes our planet in light and warmth. This energy is crucial for life on Earth. This process will continue for billions of years to come. The sun's energy sustains ecosystems, drives weather patterns, and provides the warmth necessary for life. But eventually, the sun will exhaust the hydrogen fuel in its core. This marks the beginning of the end for our star. When this happens, the outward pressure from nuclear fusion will no longer be able to counteract the inward pull of gravity. The balance that has kept the sun stable for so long will be disrupted. The sun's core will begin to contract, heating up even further. This intense heat will trigger the fusion of helium into heavier elements. This heating will cause the sun's outer layers to expand dramatically, transforming it into a red giant. The sun will swell to many times its current size. This red giant phase will be a tumultuous time for our solar system. The increased size and luminosity of the sun will have profound effects on the planets. The expanding sun will engulf the inner planets, including Mercury, Venus, and possibly even Earth. The fate of our planet in this scenario is uncertain, but it will undoubtedly be a time of great change. Eventually, the sun will shed its outer layers, leaving behind a hot, dense core known as a white dwarf. This remnant will slowly cool and fade over billions of years. The white dwarf will be a shadow of the sun's former glory, a faint ember in the vastness of space. This is the final stage in the life cycle of a star like our sun. But even in death, stars contribute to the cosmos. The material ejected during the red giant phase will enrich the surrounding space, providing the raw materials for new stars to form. And so, the cycle of stellar life continues. From blazing glory to faded embers, the life of a star is a testament to the dynamic and ever-changing nature of the universe. Each stage, from birth to death, plays a crucial role in the cosmic dance. The universe is filled with stars at different stages of their life cycles, each one telling a unique story of creation, evolution, and transformation. It is a reminder of the incredible forces at work in the cosmos, and the beauty that arises from them. A timescale of epic proportions, the long road to black dwarfhood. This journey is one of the most fascinating and prolonged processes in the universe, stretching far beyond the limits of human imagination. The transformation from a red giant to a black dwarf is a slow and drawn-out process. It is a cosmic metamorphosis that unfolds in stages, each more intriguing than the last. It unfolds over billions, even trillions of years. This immense timescale is a testament to the slow and steady nature of stellar evolution. This timescale is almost impossible for us to grasp. To put it into perspective, the entire history of human civilization is but a fleeting moment compared to the lifespan of a star. It dwarfs the entirety of human history. From the dawn of humanity to the present day, our existence is merely a blink of an eye in the grand timeline of the cosmos. As the sun sheds its outer layers during its red giant phase, it will leave behind a dense, hot core known as a white dwarf. This core is the remnant of the star's former glory, a compact object that holds the memory of its past. This white dwarf will be incredibly hot, with a surface temperature of tens of thousands of degrees Celsius. Despite its small size, it will shine brightly, a beacon of residual heat in the cold expanse of space. But it will no longer be generating energy through nuclear fusion. The nuclear reactions that once powered the star have ceased, leaving the white dwarf to cool and fade over time. Over eons, the white dwarf will slowly cool down. This cooling process is a gradual decline, a slow release of the heat stored within its core. It will radiate away its residual heat into the coldness of space, gradually fading in brightness. The once brilliant white dwarf will become dimmer and dimmer, a shadow of its former self. This cooling process is incredibly slow. It is a testament to the enduring nature of stellar remnants, which can persist for billions of years. It takes billions of years for a white dwarf to cool down significantly. This prolonged cooling period is a key phase in the journey towards black dwarfhood. The time it takes for a white dwarf to become a black dwarf is truly staggering. This transformation is not just a matter of millions or billions of years, but extends into the realm of trillions of years. Current estimates suggest that it could take 100 trillion years or even longer. This is a timescale that defies human comprehension, stretching far beyond the current age of the universe. This is far, far longer than the current age of the universe, which is estimated to be around 13.8 billion years old. The journey from white dwarf to black dwarf is a testament to the slow, inexorable march of time in the cosmos. The transformation of our star, from yellow sun to cold, dark remnant. The transformation from a vibrant yellow sun to a cold, dark black dwarf is a dramatic one. This journey spans billions of years, a cosmic dance of energy and matter. As the sun exhausts its fuel and transitions through these stages, its physical properties will change drastically. Each phase marks a significant shift in its structure and behavior. During its red giant phase, the sun will swell to an enormous size, hundreds of times its current diameter. This expansion will engulf the inner planets, including Mercury and Venus, and possibly even Earth. Its surface temperature will decrease, giving it a reddish hue. This cooler yet larger sun will dominate the sky, a stark contrast to the yellow star we know today. But its luminosity or total energy output will increase dramatically. The red giant phase will be a period of intense brightness, outshining its previous state. As a white dwarf, the sun will shrink down to a size comparable to Earth. This transformation will be a collapse of its outer layers, leaving behind a dense core. Its density will become incredibly high, with a teaspoonful of white dwarf material weighing several tons. This immense density is due to the compact nature of the white dwarf's matter. However, its luminosity will decrease significantly as it radiates away its residual heat. Over time, the white dwarf will cool and fade, becoming less and less visible. Finally, as a black dwarf, the sun will be a cold, dark, and incredibly dense object. This final stage is the end of its life cycle, a silent witness to its former glory. It will have a size similar to Earth, but a mass much greater. The black dwarf will be a compact remnant, holding the mass of a star in a space no larger than our planet. It will no longer emit any significant light or heat. The black dwarf will be an invisible object, detectable only by its gravitational influence. It will be a ghost of its former self, a stellar remnant lurking in the depths of space. This cold, dark remnant will drift through the cosmos, a testament to the life and death of stars.
Don't forget to like, subscribe, and share this video. That's all for Nifty Narrations.